Right now, thousands of silent machines are speeding over your head. They travel at over 17,000 miles per hour in absolute darkness. Their sole purpose is to beam internet down to the ground. Yet, most people have no idea how space data reaches them. How does a satellite mesh in space deliver high-speed web browsing? Traditional internet requires burying millions of miles of physical cables underground. But cables cannot easily reach remote mountains, deserts, or open oceans. Space infrastructure solves this problem by bypassing terrestrial barriers entirely. Older internet satellites parked extremely far away caused massive, frustrating delays. They sat 22,000 miles high, requiring long signal travel times. Starlink changed this entirely by moving satellites much closer to Earth. They operate just 340 miles above our heads. This drastic distance reduction cuts signal latency down to milliseconds. The entire operation relies heavily on three separate, interconnected components. First is the user terminal, a highly advanced phased array antenna. It steers beams electronically without moving a single physical part. Second is the massive satellite constellation orbiting actively in space. Because they are close to Earth, they must move constantly. Your ground dish hands off connections from one satellite to another. Third are the ground stations, which connect directly to physical fiber networks. Your signal leaps from home to space to the ground network. Newer versions use infrared lasers to talk directly between satellites. Light travels faster through the vacuum of space than through glass. This makes long-distance data transmission incredibly fast across oceans. Large ocean vessels now get high-speed access anywhere on Earth. Commercial aircraft use this network to offer continuous, stable Wi-Fi. First responders deploy mobile units during critical emergency rescue missions. Setting up the hardware takes minutes instead of months of digging. Phased array technology handles massive bandwidth loads with ease. Low orbit placement makes interactive video calls perfectly fluid. The distributed network design ensures 0 single points of total failure. However, the system requires a completely clear view of the sky. Heavy tree canopies or tall concrete structures block signal paths easily. Extreme rainstorms or heavy snow can degrade high-frequency radio waves temporarily. Managing thousands of rapid objects increases the risk of orbital collisions. Reflective satellite surfaces also create persistent light streaks for ground telescopes. Engineers are launching much larger, next-generation spacecraft with advanced capabilities. These newer models link directly to unmodified consumer smartphones without dishes. This technology enables text messaging from the absolute middle of nowhere. Similar satellite architectures will eventually provide internet connectivity on Mars. Starlink is not just a collection of metal boxes in space. It is a dynamic, shifting infrastructure web that wraps our planet. It silently rewrites how humanity accesses shared digital knowledge every day. Next time you go online, appreciate the invisible network above. Data travels through space at light speed just to reach you. The orbital highway is operational, keeping our entire world linked together. Subscribe to Node 01 to decode more hidden engineering achievements. We unmask the complex mechanics driving our hyper-connected modern digital era. Keep exploring the incredible brittle breakthroughs that actively shape our collective future. Node 01, Technology, Decoded. Thank you for watching this breakdown.